Hello everyone. Today we are going to finish not the rest of the chapter, but the third lecture of the chemical calculations and equations. Uh, First of all, let's start with example 3.6. Example says calculate the number of moles of released oxygen from heating of 1.65 grams of KClO3 according to the following equation. So we have an equation right here, and we want to calculate the number of moles. So N equals M over M capital. So we will go through everything. So what is known here is that the mass of KClO3 is known. So we are going to calculate the mass of, or the number of moles of KClO3, the known one, okay, and from the result we will be calculating the number of moles of oxygen. So we have this is known, okay, and this is unknown. Now, what we are going to do here is to find out the molar mass of KClO3 as I taught you in the previous lecture. This is how to calculate it. So how many moles of K is 1 times 39, which is the 39 right here is going to be given in the question. 39 and 35.5 for the chlorine and 16 for the oxygen. So you got this here, 122.5 gram per mole. This is the molar mass of KClO3. Now, normality equals number of the mass of KClO3 over the molar mass of KClO3. And then this is given, and we just calculate this one, okay, and we got the moles of KClO3. Step 2, from the moles of KClO3 we can calculate the moles of O2. So normality for KClO3 or for the oxygen equals the number of moles of KClO3 times 3 moles like from the equation, okay, and 2 moles of KClO3 also from the equation right here, okay, and we get 0.02 moles of O2. This is number of moles of oxygen. This is all about the number of moles and how to calculate it. Now let's move to the another subject, which is the limiting reagent that determines the products. So sometimes when we do a reaction, we know that we need only like 1 mole from this substance to react with 2 moles of another substance to give us 3 moles of the products. So the purpose of determining the limiting reagent is that it would be a substance in the reactant side, okay, that will be determine how many moles of the product. So let's say that we have nitrogen right here, and we have hydrogen, and we got 2 moles of NH3 of ammonia, all right? So for this example, for this equation, which one is gonna be determining the number of moles of the product? It could be the hydrogen or the nitrogen. So we will be going through that. So let's say that we have like 1 moles of nitrogen, so we need only 1 moles or 1 mole of nitrogen, okay, to react with the 3 moles of what? Of hydrogen to give us 2 moles. Let's say that we have reacted 2 moles of nitrogen instead of 1 moles, which is the one that we required. Let's say we react to 2 moles with 3 moles of hydrogen, and then we get 2 moles of NH3. From this equation or from this explanation, we can predict that there is only 1 mole of nitrogen that has reacted with 3 moles of hydrogen to get 2 moles of NH3. So which one has determined the product? The nitrogen or the hydrogen? No, the hydrogen. Why? Because it required only 1 mole of nitrogen, and the other mole of nitrogen has not reacted, so it stays in the solution. So it's unreacted stuff. So we will be calculating that mathematically, okay, and then we will be able to determine which one could determine the product, either the hydrogen or the nitrogen. Okay. Now, so first of all, for like the previous equation, N2 plus 3H2, it gives us 2NH3. So the number of moles of the product over the number of moles of the reactants, one of them, the nitrogen. Okay, so 2 to 1. For the NH3 with the hydrogen is 2 to 3, the ratio. Okay, now after we got everything here, we can calculate the or use the number of moles of one of the reactants. Let's say the nitrogen is 2 moles of nitrogen, okay, times 2 moles of NH3 over 1 mole of N2 gives us 4 moles of NH3. If we start with like 2 moles of or 3 moles of hydrogen times 2 moles of NH3 over 3 moles of H2 gives us 2 moles of NH3. So now from these two values we can determine which one is the limiting reagent. So we will see that in the examples, because this is kind of complicated and you guys need to like pay attention to it very carefully, and we will be having some examples, and through those examples you will be able to understand it very well. Example 3.7, according to the following reaction, titanium plus 2Cl2 gives us titanium Cl4. Now, when 1.8 moles of titanium, so if we have the number of moles of what? Of titanium, and 3.2 moles of chlorine are mixed. So we are mixing two different materials, chlorine and titanium. Which is the limiting reagent that determines the product? So we have 2 moles, 1.8 moles of the titanium and 3.2 moles of chlorine. We want to see which one is the limiting reagent. Which one? It's either going to be the titanium, okay, right here, or the chlorine would determine what? The TiCl4, titanium tetrachloride. So let's go through each one like individually. So now you don't need to do this step, okay, nor this one. You don't need to do them. So we will start over from this point, okay, because we don't need these two steps, okay. Don't even like look at them. Let's get started. We will be wait, just a minute. I'll show you something that you guys will be able to do any example or any question regarding the limiting reagent very simply and very easily. Now, so we have titanium here, right? And we have chlorine. We will take titanium and compare it with what? With TiCl4. And then we will take chlorine and compare it with TiCl4 and see the result. So let's get started. For the first one, we will be comparing the titanium with TiCl4. Now, how many moles in the like in the question that we have already mixed with the chlorine? So when 1.8 moles of titanium, so we have used 1.8 right here, 1.8. So we write down 1.8 mole of titanium, okay, times. So we will be dividing the number of moles in the equation. So for the for the missing, which is the TiCl4 over Ti, okay, TiCl4, how many moles? We have nothing here, so it's 1, okay, TiCl4 over 1 mole of the titanium. So 1 over 1 gives us the same thing, 1.8 moles of TiCl4. This is the first one. The second one we'll be doing here is to do the same thing as we did with the titanium, except that we will be do a comparison between chlorine and TiCl4. The chlorine, the reactants, and TiCl4 is the product. So 3.8 from the question. So we say like 3.2 right here, moles of chlorine, okay, it's right here, times the number of moles of TiCl for how many? So we have 1, and for the chlorine we have 2, so 1 over 2 right here gives us 1.6 TiCl4. Now, which one is less than the other? So the smaller value would be the limiting reagent. Then, so which one? So the 1.8 and we have 1.6. So 1.6 is the limiting reagent? Yes, it is. Now, did you understand this? It's easy. So as a number of moles of TiCl4 formed from the like reacting 3.2 moles of Cl2 is less with the titanium, so the Cl2 is the limiting reagent that determines the product. Okay.